All right, so we're going to do a little bit more with transformations because looking at the homework, it was definitely a lot more confusing than I wanted it to be. So let's take a look at a little bit more of how we can do these problems, and then I'll go through some of the homework ones with you as well. So the first part I want to go back over here is when we have a vertical stretch or compression, and when we have a horizontal stretch or compression. You will have a vertical stretch or compression when your new equation has a number outside of the f of x. So like 2 times f of x. What that means, if your original point was some value x and y, the x is going to stay as is, and you are going to double the y's. So what happens is your graph is vertically stretched, so it is more narrow of a graph. If you have, say, 1/3 in front, process is the same. Your x will stay the same. All of your y's will be multiplied by 1/3. And then what happens is your graph is compressed. So it's going to be wider. Okay. Horizontal stretches or anything you attach to the x is always opposite of what you think. So remembering that if we do this, x plus 2, f of x plus 2, what this means is I go left 2. I go the opposite of what it says. Usually plus 2, I would think, add 2, we're going opposite. So the same thing is going to happen here. If I have f of 2x, what's going to happen is I'm not multiplying the x's by 2. I'm actually going to divide all of the x's by 2. So my original point, I'm going to take each x divided by 2, and then the y's will stay the same. What is happening here is this is a horizontal compression. So this is going to compress your graph. If I have a fraction smaller than 1, so let's say 1/3 inside here, I take my original point, and instead of dividing all of my x's by 3, I'm actually going to times all of them by 3. And what it's going to do is it's going to stretch my graph horizontally. So stretch horizontally, compress horizontally. One thing we need to remember as well is if I ever see something like this, 2x plus 4 inside, I must factor out the piece that's in front of the x. So f, I'm going to pull out the 2, and then it's going to be x plus 2. So when I read this, this is going to be a compression of 2, and then this is going to be left 2. So I always have to do this GCF factoring out first before I can actually go through and graph anything. All right, now that that is cleared up, I'm going to pull over some of the homework problems for us to take a look at. So here's one where we're describing a transformation. We have a negative outside, x plus 2, and then minus 1. So I know that's going to be left 2, and then down 1. And then that negative in front is going to reflect it over the x-axis. Okay, so let's look at this one. The 2 is out front, and according to our notes, that is going to make it narrower when the number is larger than 1 out front. So it's going to stretch it. by a factor of 2, and then we are shifting 3 to the right because it's minus 3. So inside, that's always the opposite. All right, so in order to do this one, I need to take this over here. So f of negative x plus 5. So let me do this. F of negative x plus 5. So anytime there's something in front of the x, you got to factor it out. So negative, now I'm going to have the x, and then that's going to become minus 5. So the negative inside here is now going to be a flip over the y-axis. And then this minus 5 is actually telling me I'm going to go right 5. Get my homework page back up here. Reflected over the y-axis and shifted 5 right. Okay, so this one we have a 1/2 in front. When it's in front of the f, it's a vertical change, but now we're going to compress it because it is smaller than 1. So we're vertically compressing by a factor of 2. And then let's see, if it's x minus 4, we're going to go right 4 because it's the opposite, and then up 3. So that's this guy down here. All right, so here's where you're going to actually start moving the points. Your original graph is in blue. And we now want to draw f of 1/3 x. So remembering that when it's inside of the parentheses here, we do the opposite of what it says. So it says 1 divided by 3, but we're going to actually multiply all of our x's by 3, keeping the y's the same. So the 0, 0 is going to start as it is. So instead of 1, 2, it's going to be 3, 2. Because I multiply the x value by 3. So instead of 2, 1, it's going to be 6, 1. Because I'm going to multiply the x value by 3. 3, 5 is now going to be 9, 5. Multiply the x coordinate by 3. 4, 1 is going to be 12, 1. And then 15, 0. So what we did is we have horizontally stretched this graph. Next one, if I have, let's see, the original is red. We need to move the green. So a negative in front means we're going to flip over the x-axis. So all I need to do is flip these points over the x-axis. So instead of being at 1, 2, 3, negative 3, 1, 2, 3, negative 4, I'm going to be at negative 3, positive 4. And then I need to flip the direction of my graph because it's going to, everything's flipped over. And it should look like both of these are going to meet. They should look perfect like that. Good to go. All right, next one. Inside, our original graph is blue. So inside, we now want to do f of 3x. Remember, when it's inside the parentheses, we do the exact opposite of what it says. So instead of multiplying the x's by 3, we're going to divide all of them by 3. So instead of 1, 3, it's going to be 1/3 3. So we're shrinking it all back. We're compressing it. So instead of 2, it's going to be 2/3. So 2 over 3 is 2/3. 3 divided by 3 is 1. So 1's going to be at that same height. So all I'm doing is changing the x value, which is shrinking the graph back. And then 4 over 3 is 4/3. So it has that same general shape. It's just going to be scrunched further towards the y-axis. All right, so now we're going to combine them. And here's where it's going to get a little tricky. we have a few different things that are going to happen. So what I'm going to do is I'm going to copy this guy on the slide over here. F of negative x minus 5 minus 4. F of negative x minus 5, and then outside I think it said minus 4. Let me just double check that. Minus 4. Okay. Remembering that we have to, if there's anything in front, we need to pull that in front out. So negative 1, I'm going to factor that out, x plus 5, and then outside is a minus 4. So this negative 1 inside here is a flip over the y-axis. And then once it flips over, we're then going to go instead of plus 5, so that's left 5, and then down 4. Flip it over the y, and then we're going to go left 5 and down 4. So starting where it is, if I flip it over the y-axis, this point isn't changing. And then I'm going to go 1, 2, 3, 4, 5, 1, 2, 3, 4, down 4. Now, the whole graph, though, should be flip-flopped. So the point that I had over here, let's see, if we follow this, it should follow that same pattern. It should be a over 1, up 1, over 1, up 1, over 1, up 1. You can see it's hitting all along the corners there. So I know my graph is good. So you can pick any point here. So let's say we pick 3, 3. We flip it over the y-axis. That's going to go to negative 3 over here. Then go left 5, 1, 2, 3, 4, 5, down 4, 1, 2, 3, 4. My point is correct. And I'm good to go. Okay, the original is red. We want to move this one. So the only thing we have to do here is this is where it starts. And we have to go, let's see, instead, if it's x plus 2, we're going to go left 2. And then outside is plus 3, so up 1, 2, 3. And that's the only thing we have to do with that one. There's no flipping or compressing or anything like that. All right, let's go this guy here. Again, the dashed one is where we start. And all it wants us to do is shift left, right, up, and down. So x minus 2 means I'm going to go 2 to the right, and then outside plus 4 is up 4. All right. This one. Is that what I did already? Oh, it's plus 4 instead of minus 4. So f of it's negative x minus 5 and now plus 4. So it's going to look similar, negative 1x plus 5, but then it's plus 4. So we're still flipping over the y-axis, but now we're going, after our left 5, we're going up 4. Let me get my homework back up. Okay, so flipping it here does nothing. Moving it 1, 2, 3, 4, 5, 1, 2, 3, 4. Okay, but again, we're flip-flopping the way that it looks. So the whole graph should switch to the opposite direction here. And I can verify that here. If I took that point 1, 1, flip it over the y-axis, it's going to move it to negative 1, 1. Then move it left 5, 1, 2, 3, 4, 5, up 4, 1, 2, 3, 4. Given our original graph is the red dashed curve, we're going to move the green to the negative of f of x. When the negative's out front, that means everything's flipping over the x-axis. So let's see. This point is down here at -5, so it's going to go up +5, and then it's going to flip over. Right now, I currently see it going up over 1 to this point. I need to flip that over, and I'm going to go down to over 1, and you'll see that they should intersect at those similar points here. Given our original graph, find f of x minus 3 and then +1. So x minus 3 means we're going to move right 3, and then the +1 is up 1. All right, similar one here. X minus 5 means we're going to go to the right 5, and then a -4 on the outside means we then go down 4. So these ones are just, some of these are just shifting that vertex point. Here's another one where we have a negative in front, meaning we're going to flip it over the x-axis. I'm going to start with where I have it. And instead of it being up at 1, I'm going to have it down at -1. And then what I want to do is I want this graph to then flip the opposite direction. And I'm going to know it's right when those points match here, where they intersect here. Both of these cross the x-axis at the same spot. All right, so we have the red dashed curve. We're now going to, again, flip it over the axis. So let's see. B is currently up at 2, so I'm going to move this down at 2. A is currently up 3, so I'm going to move it down 3. C is currently up 1, so I'm going to move that down 1. And then D is currently here. We got to make it move the other direction, up 6. And I should see that it looks like if I were to fold it along this line here, that it would fall right on top of itself. All right, so here's another one where we have a 3x. Remember, when it's with the x, it's the opposite of what it says. So instead of timesing by 3, we are dividing all of our x's by 3. So 1 is currently here. I need to divide it by 3, so that's 1/3. Here's the current point. I need to divide the x by 3. 2 divided by 3 is 2/3. Here's this point. 3 divided by 3 is 1. And then we have our compression. This one is f of 2x. So again, it's with the x, so we're going to do the opposite of what it says. So instead of multiplying the x's by 2, we divide them all by 2. So here's my current x value, cut it in half. Here's my current point is at 2 for the x, cut it in half. Next point is at 3, 5. I want to cut it in half. So half of that is 1.5. Next point is 4, and if it's easier, you can line all these up and move them back. Half of 4 is 2, and 5 divided by 2 is 2.5. So again, we have a compression. Now comes ones that are going to get a little trickier. So f of 1/3 x minus 1 plus 1, 1/3 x minus 1. And then on the outside is +1. Anytime there's something attached to the x, we have to pull that out first. If I pull that out, though, I need to figure out what this is going to be. And it's going to be a 3. So let me explain how I know that. If I multiply this back in, 1/3 times x is 1/3 x. 1/3 times 3 is 1. So what this is telling me is my current, whether it's a absolute value or a curve graph, that vertex point is doing this part here. It is shifting, let's see, that's going to be right 3 and up 1. And then this piece here, because it's a 1/3 attached to the x, is going to then tell me that I'm doing a stretch times 3, the opposite of it. So right 3 up 1, and then a stretch times 3. I'm going to find this original one here, right 3 up 1. And then I'm going to find any one of these points here. So if I go to this point here, 1, 1, 2, 2, I need to take the x value and times it by 3. So 2 is now going to be at 6. 6, 2, 6 over, I'm not going to be able to do that. Let's do this. 1 up 1 over 1 is what it's supposed to, is the original graph. Do it this way. It's now stretched 3 times that. So instead of going up and over 1, we're now going up and over 3 times that. So there's my horizontal stretch. Okay, the 3 is on the outside here. So 3 times the f of x plus 4 and then minus 3. So I'm going to start with where my vertex goes. So x plus 4 means I go back 4, and then minus 3 means I go down 3. Now, the original graph is an up 1 over 1 here. You can see from here to here, the next spot is at 1, 1, up 1 over 1. What I want to do, though, is that needs to be 3 times as much. Instead of going over 1, up 1, I need to go over 1, up 3, because I'm stretching that y value 3 times as high. Instead of going over and up 1, I'm going over and up 3. I went up 4. I apologize. Let me fix that here. I went up, instead of going up 1 over 1, I need to go up 1 over 3. So that's what I did wrong. It should have been up 1 over 3. I accidentally went over up 4. So just be careful as you're doing those. All right, next one. So start with where my vertex moves. Plus x plus 1 means I moved left 1. Hold on, and I'm going to make that, there we go, the original graph. I like to have it as the original graph first. Okay, so left 1 and then down 3. Okay, so that's my current normal point. But now I need to go 1/3 as high. Instead of going over up 1 over 1, up 1 over 1, up 1 over 1, or up 3 over 3, I need to pull that down 1/3 as much. So it was up here as up 3 over 3. So if I need to drop it 1/3 of what it was, it's going to be up 1 over 3.